we were continuing our discussion on stereolithography, that is wet polymerization technique of rapid prototyping. And we in the last lecture I told that we will continue our discussion on material which are used in stereolithography techniques. Okay, so these materials are basically called photopolymerized, the material which are used in wet photopolymerization. Okay, so these are sometimes called as photopolymerization materials, right? So this is our lecture number 4th, and we will, in short, we will talk about these materials. I will not go much in the chemistry part because in polymerization there are some reactions takes place, but I will not be touching that part. I expect that if you are more interested, then you can even Google it about the chemistry part. Okay, so let us come to the materials. These materials are called or also called as UV curable photopolymers. Okay, why these are called UV curable photopolymers? Because we are using UV radiation to cure these materials. Okay, so going back to the history of these materials, photopolymers were developed in 1980s, around 60 years back. The types of radiation which is used to cure, that is to solidify these, curing means solidification of your material, that is photopolymers. Okay, so to solidify these, when these photopolymers comes in contact with UV radiation, these materials get solidified. Some chemical reaction takes place in the photopolymer, and they get solidified. Okay, so the types of radiation which is used, first one is your gamma rays, X-rays, then electron beam, then ultraviolet radiation, and in some cases we use our visual light source also as your as the type of radiation which is used to cure your photopolymers. Okay, so in stereolithography system, generally we use UV radiation, in which there are a few here. These are few types of printer which were developed, which are using some kind of laser source, that is helium cadmium laser is used in this particular type of printer. The company 3D System has developed this SLA 250 printer. Okay, then there are other other printers, other 3D printers where other type of solid state lasers are used. Among them your neodymium yttrium type laser is commonly used. So these neodymium laser is in market. If you talk about this name of this laser, it is Vendette lasers. Okay, so these are the basically radiations which are used in curing your photopolymers nowadays. This is about SL stereolithography system, and under stereolithography, then we have mass projection DMD systems. Okay, in that case also we use UV laser and sometimes your visual light as in order to cure your photo polymer. Okay, so going forward, UV curable, we will talk specifically about the photopolymer which can be used, which can be cured using your UV radiation. Okay, so the thermoplastic polymers that are typically injection molded have a linear, you can see this linear molecular structure, as well as branched molecular structure that allow them to melt and solidify repeatedly. So those who have gone through this material science course in your during your engineering graduation days, you might have heard about thermoplastic polymers. So thermoplastic polymers are those polymers which get solidified upon heating. Okay, so what transformation goes in thermoplastic polymers, we will look into it in next slides. Okay, so the typical type of structure which are available in thermoplastic polymers are linear, branched, and cross-linked. The SL, when I have typed SL because I will not each time read it as stereolithography. Okay, so in short I have wrote it as SL. SL photopolymers are cross-linked, that is the third category, and as a result do not melt and exhibit much creep and stress relaxation. Okay, so the SL polymers, they are not easy to melt. Okay, yes. So talking more about your SL polymer, your SL photopolymers, the main ingredients of your SL photopolymers are photoinitiator, reactive diluent, flexibilizers, stabilizers, and liquid monomers. Okay, so in wet polymerization technology, we have a wet or a large tank of liquid in which your photopolymer is filled. Okay, and this photopolymer have 5 ingredients, particularly photoinitiator, reactive diluent, flexibilizers, stabilizer, and liquid monomers. Okay, when your ultraviolet rays impinges on your SL resin, this is your SL resin, and the due to impingement of your ultraviolet radiation on this liquid photopolymer, what happens? The photoinitiator undergo a chemical transformation and become reactive with the liquid monomer. Okay, so these photoinitiators, there are some chemical transformation. That chemistry part, I have not wrote those chemical reactions in these slides. But if you want to go in detail, you can check on Google or on even on Wikipedia. If you search free force radiation, you will find out much detailed chemical transformation which goes on in the case of your when your UV radiation impinges on your SL resin. Okay, so as soon as this UV radiation falls on your SL resin, it becomes reactive and it reacts with your liquid monomers. A reactive photoinitiator react with a monomer molecule to start a polymer chain. The subsequent reaction occur to build polymer chain and then to cross-linked creation of strong covalent bond between these polymer chains. Okay, so the term which is as soon as this building of polymer chain start, this process is called polymerization. So the polymerization is the term used to describe the process of linking small molecule, that is monomer, into large molecule, that is polymers composed of many monomer units. There are two types of photopolymers from the chemistry point of view. There are two types of photopolymer. First one is called your free radical photopolymerization. This is also known as acrylates. Then this is in acrylate, sorry. This kind of particular polymerization, that is free radical photopolymerization. It is under acrylate materials. Then another category is cationic photopolymerization. It is in epoxies and vinyl ether. So this is your epoxy and this is your vinyl ether. Under epoxy, you can see there is a ring type of bonding. So we will see how this this free radical photopolymerization and cationic photopolymerization takes place. Okay, so free radical photopolymerization was the first type that was commercially developed. These SL resins are acrylates. Acrylates, there are these terms, you may find it difficult to pronounce, but once you go this slide, you will be able to, even not only pronounce, you will find difficult to remember. Okay, so you can go through this PPT when I circulate it. So talking about acrylates, acrylates form long polymer chains once the photoinitiator become reactive, building the molecule linearly by adding monomer segments. The cross-linking typically happens after the polymer chain grows enough so that they become close to one another. Acrylate photopolymer exhibit high photospeed, react quickly when exposed to UV radiation, but have a number of disadvantages, including significant shrinkages and tendency to warp up and curling. The most common cationic photopolymer are epoxies, although vinyl ethers are most commercially available. But in the case of your cationic photopolymers, we use epoxies commercially. Okay. So moving ahead, epoxy monomer have ring, as I shown in this figure. These epoxy resins have a ring. Okay, so the epoxy monomer have rings when reacted, and these ring open, resulting in sites for other chemical bond. Okay, so as soon as your UV radiation falls on this epoxy resin, this ring reacts, and this ring instead of closed, it get opened. Okay, so the ring opening is known to be impart minimum volume change on reaction, become the number and types of chemical bonds which are essentially identical before and after reaction. Epoxy SL resin have much smaller shrinkage and much less tendency to warp up and curling. Okay, so in previous type of photopolymers, that is in acrylic, we had the problem of this warping and curling, but in the case this problem was in the case of your acrylates, but in the case of epoxies, this problem is not there, because shrinkage is very less in the case of your epoxies as compared to your acrylates. Okay, so so epoxies SL resin have much smaller shrinkages and much less tendency to warp up and curling. Almost all commercially available SL resin have significant amount of epoxies. So these are the epoxy. This is the molecular structure of your one epoxy resin. Moving ahead, how your this free radical photopolymerization takes place. In free radical photopolymerization, the polymerization of SL monomer is an exothermic reaction. That is, it generates heat is generated when this polymerization takes place. and approximately heat of reaction is around 85 kilojoule per mole for acrylate monomer. Despite high heat of reaction, a catalyst is also needed to initiate the reaction, and normally your photoinitiator act as your catalyst in your polymerization process. So here you can see as soon as your light impinges on your photoinitiator, one free radical is formed, and this free radical further reacts with your monomer. So M stands for your monomer, I is for initiator, and Pi indicates your photoinitiator. Okay, so as soon as your ultraviolet radiation falls on your Pi, that is photoinitiator, this was one of the gradient in your SL legend. Okay, so as soon as your ultraviolet rays falls on your Pi, that is photoinitiator, it becomes a free radical. A free radical is formed, and this free radical acts as your catalyst. Okay, so it reacts with other molecules of your liquid monomer. Okay, so your free radical then further combines with monomer. Not only one monomer, one free radical may combine with 1000 monomers. Okay, so your free radical, one free radical can easily lead to polymerization of over 1000 monomers. And this process is, this process continues from first it is getting, initiated. This polymerizes your first monomer, then second monomer, and say up to 800 monomers, your one radical, or up to 1000 monomers. So this process is called this process is called propagation of your polymerization. So then certainly after propagation, as soon as we stop the UV radiation or exposure of UV radiation to this liquid photoresin, your creation of free radical is stopped as soon as we stop your UV laser. Okay, so as soon as you stop your UV laser, what will happen? Your propagation will stop after certain time, because there will be no free radical formation because there is no laser supply, okay, or UV supply. So this process after propagation, this is followed by termination, and we will be discussing how this termination takes place in the case of your free radical polymerization. In general, longer polymer molecules are preferred because these yield higher molecular weights. This indicates a more complete reaction. Okay, so here you can see up to this, I hope you could understand how this propagation takes place. Propagation of that is the increment in your polymerization techniques. Polymerization takes place. Okay, so the first step is you expose your SL resin to ultraviolet rays. Then as soon as this your photoinitiator comes in contact with your UV laser or UV rays, your free radical is formed, and this free radical, one free radical can lead to polymerization of 1000 monomers. Okay, so but obviously for continuation of this polymerization, this creation of free radical is required, and for creation of free radicals, what we need UV rays. Okay, so So obviously we have to decide for how much time we should expose our SL resin into your UV rays or UV or laser beam, whatever source we are using for creating this free radical uh, formation. Okay. So as soon as this process is completed, or the amount you whatever you have decided, you will stop the amount of, if your amount of your free radicals are sufficient, you will stop exposure of your UV laser. Okay. So moving ahead, how this termination process takes place, we will try to understand. Uh, because since there are no free radical available, obviously this process will stop after a certain time. But how this termination takes place, there are basically three regions: recombination, disproportionation, and occlusion. Recombination occurs when two polymer chain merge by joining uh, two radicals. Okay, so this is called recombination, and your uh, when your two radicals are joining, your process chain is merged and recombination takes place. Okay, so it may sometimes result into termination of your polymerization process or the propagation of polymerization. Then the second issue is disproportionation. Okay, so disproportionation involve essentially the cancellation of one radical by another without joining. Okay, this may also happen when this may be one of the reason for termination of your propagation of polymerization. Okay. Then third point, which normally happens when we stop exposure of UV rays on your SL region. Okay, so occlusion occurs when free radical becomes trapped. Okay, so these are get trapped within a solidified polymer. Your free radical is trapped by solidified polymer, meaning that the reaction site remain available. It means it is not having liquid monomer in its surrounding boundary. So they are prevented from reacting with other monomer or polymers by the limited mobility within the polymer network. These occluded sites will most certainly react eventually, but not with another polymer chain or monomer. Instead, they will react with the oxygen and another reactive species that diffuses into the occluded region. Okay, so these are four stages in the case of your polymerization process. First, your free radical is formed. Then this free radical reacts with liquid monomer available in your cell resin. Then this initiation is converted, this reaction of your free radical with liquid monomer, one monomer is, may go long up to up to 1000 monomers. Okay, so your one radical may polymerize up to 1000 monomers, and this process is called propagation. And subsequently, the last stage in last process in the case of polymerization is the termination of your this propagation. Okay, so after a certain period, if you have stopped exposure of your UV radiation or UV electron beam or visible light, whatever source you are using, this termination process start, and the reason for termination of your polymerization may be recombination, disproportionation, and occlusion. Okay, so Then we have this was about free radical polymerization. I have not touched the chemistry part, but those who want to work particularly in this area, that is stereolithography, they must go in detail. They can Google it easily. There are not more than 2-page write-up. You can easily understand the content which is available on Wikipedia. Then we have second type of photopolymerization, that is cationic photopolymerization. In cationic photopolymerization, it is more or less, the structure is more or less like your free radical polymerization. But here, what is the difference that you have to understand? Because in this cationic type of polymerization, we are using epoxies and vinyl ether. Okay, so obviously the rings are there. Okay, in cationic type of polymerization, the photoinitiator generates a cation as a result of laser energy. The cation reacts with a monomer. Propagation occurs to generate a polymer, and termination process completes the reaction. Okay, so these are the three things, that is uh, your photoinitiator generate a cation because of exposure to the laser energy, and your cation react with the monomer. So the when I'm saying monomer, it is in liquid form. Okay, so this cation reacts with monomer and it generates a polymer. So this monomer is converted into solid polymer. And if we have stopped exposure of your laser energy, then obviously this will lead to the termination of your polymerization process. A typical catalyst for a cationic type polymerization is Lewis acid. Initially, cationic polymerization, was not was not being used until unless in 1990 some advances in the area of microelectronic industry, people took interest into this cationic, that is cationic type of polymerization. Okay, because this technology was used for microelectronics industry only initially. Okay, so in the case of cationic, the ring opening reaction mechanism of epoxy monomer is similar to the radical propagation in acrylates. Okay, so in the case of free radical photopolymerization, we have radical propagation, but in the case of your cationic photopolymerization, we have ring opening reaction, and its mechanism is almost or more or less similar to the radical propagation in the case of your acrylates.